Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Now already we have discussed about loops. Now in this session we'll talk about arrays. See, array is a collection of homogeneous data elements. So this is a definition, common definition. That's a collection of same type of data elements. It's a collection. Actually, array is used for storing list of elements. List of elements means list of numbers, list of marks, list of prizes, list of item numbers, list of roll numbers, so on. So mostly when we deal with large size data, the data becomes list. If I ask you to write down the names of students who are interested in taking parts in some sport, then you will prepare a list. So in a table, you will prepare a list, right? You will make a table-like thing and you write the name and their roll number and in which sport they are interested in. So you'll mostly come up with some table. So it is nothing but a list of names and list of roll numbers, list of sports. So this is a common practice that we have the collection of data. So in our programs, we have seen how to declare the variable. Suppose we declare the variable integer x, then how many values I can store in this one? I can store just one value, and we say that this will occupy memory space like this, and as integer is 4 bytes, it will occupy 4 bytes, and the value 25 is stored here. So this is just for one element. What about if I have set of elements or list of elements? So we can store array. We can store them in an array. See, for storing that, I should take integer. I'm taking integer only, mostly it's easy to write. So though there are a lot of other data types, okay. So always I write integer. Data type means integer as a standard we are following, okay. I can create an array of some size, a new int of size 5. Now, how this looks like, see this. I can store 5 integers now, right? I can store 5 integers now. This is 0, 1, 2, 3, and 4. And this name of this one is A. It is created like this. So now, just I was able to store one number. I can store 5 numbers here, 8, 16, 22, 39, 44. I can store 5 different integers here. Five integers I can store. So this is nothing but list of elements or collection of elements. So yes, arrays are used for storing list of elements. Now one important thing here is, like this is taking 4 bytes and these are 4 bytes. Suppose the addresses, if we talk about the address is 200, 201, 202 and 203. Then what about this? Suppose the first byte address is 300 and 301, 302 and 303. Then what about this one? This is 304 and this is 4, 5, 6, 7. So this is 308 and this is 312. So it means all these bytes are side by side. They are side by side. Total how much memory it is consuming? 5 into 4 bytes each. This is a size, right? This is size and this is size of data type. Okay, this is the size of an array and this is the size of the data type. So I'll write it as size of array and size of data type. So these many bytes it will take, so that is 5 fours, 20 bytes. And the point here is all those 20 bytes are together. So that is the reason we can access any location with the help of its index. So I repeat the points. Array can be created like this, 5 integers, all those 5 integers will be side by side and you can access any of these integers using its index and the memory is contiguously allocated, means all 20 bytes will be together. Now for accessing any of those elements, suppose I want to write 10 here, then this is 1. So I can say A of 1 assign 10. And I want to access this one, so I can say A of 3 assign 39. That's it. So this is just an introduction of an array, how an array is created and how it is accessed. This is the method of creating an array, and this is how you can access. Now, few more points. This one is actually called as a reference of an array. And this is an array object. This is an array object. This is a reference. So what is this reference? It is just like a pointer of a C++, but it is not a pointer. We don't say it's a pointer. We say it's a reference. This will have the address of this array. So it's like a pointer. So if you are familiar with the pointer of C++, you may be knowing this diagram that this points on this one, storing the address of that one. So yes, that's what it is doing, but we don't say it's a pointer. We say it's a reference. So this is a reference and this is an object. And one more last point, I'll dictate them. One more last point is that always arrays are created in heap with the help of references. So I'll dictate, you can note down the points, I'll dictate them. See, arrays use first point. Array is a set of or collection of homogeneous set of elements. Homogeneous elements. Array is a collection of homogeneous elements, means same type of elements. So first point is array is a collection of homogeneous elements. Next sentence, all elements are of same type. Third point, we can access all the elements using array name and index. We can access all the elements using array name and index. Next point, array will be of a fixed size. Array will be of a fixed size. Array name is a reference of a name. Array name is a reference of array. Array name is a reference of an array. Next, memory for an array is allocated contiguously. Memory for the array is allocated contiguously. Then, the size of the memory taken by an array is size of the array into size of the data type. Size of the array into size of the data type. And this is reference and this is object. One more point. Arrays are always created in heap. Arrays are always created in heap. Then you can take this line and draw this diagram, and also you can take this one. Copy this one, draw this one. Now let us see how to create an array. What are the methods how we can create an array? Let us check this. Integer a, empty brackets, assign new integer of size 5. This is an array. This is just a reference. This is just a reference, and this is an object. Okay, so this is a reference and this is an object. It will be pointing on that one. Okay, the object will be created in heap and this reference will be created in the stack. What does it mean? I'll explain afterwards. I'll cover a topic on this one. So this will be in the stack and this will be in the heap and it will be pointing on that one. All arrays are created in heap only. Okay, this one method, first one. Second method, I can declare array like this also. I'm using same name instead of writing A, B, C, D. I'm writing another method, so I'm using same name again. New int of size 5. It's the same thing. Third one, integer brackets, then space A, assign new int of some size. Let me take 5 only. Even you can give brackets just beside the name or after the data type also. Then fourth one, you can declare an array like this in the first step. Then A, assign new int of size 5. So the point here is that you can break this into 2 steps also. This not just one assignment is there. So assignment you can do it afterwards. Then what is this declaration of a reference? What is this creation of an object? So you can do this in 2 steps. Then fifth one, integer A, 5, 8, 9, 10, 16. This is declaration and initialization of array, and you don't have to give the size. Directly this array will be created 5, 8, 9, 10, 16, and A will be a reference to this one. Say if you look on this side, a array is created and there is a reference. And you don't have to mention the size. Like we have not mentioned the size here. Don't mention the size. Then what will be the size? Depending on the array. Okay. So this is another method. So this is declaration plus initialization. 2 things are there. Then sixth one, integer 1 reference, second reference. I can have just references of arrays. So I have 2 references. Then I will say A, assign a new int of size 5. Then I will say B, assign A. So what happens here is A is a reference to an array of some size and B is also a reference to the same array. So I have taken multiple references. Till here it was using one only. Now here I've used 2 references. So now A and B, both of them will be pointing on that one. Same array, right? Should write indices. Should. Now one more thing. Here I write, I can say integer reference A and B. Then A, assign new int of size 5 and B, assign A. See, if I declare it like this, then both are references. Both are references of array. Both are array references. So I'll make it as 7th one. See, int array, integer array, A and B. So both A and B are integer arrays. 8. Integer A. If I write like this, then this is array reference. Array reference. This is scalar variable. Scalar means simple variable or simple variable. This can have single value. This is normal variable. It's not an array. Not an array. Okay. So I will write like this. It's better. Not an array. Then who is array? Whoever is having bracket. I have not given brackets here, so this is not an array. Okay. I have given brackets for both, so both are array references. Here only one is array reference. This is not an array reference. What about this? The array reference was, this brackets were given along with the data type, so both are array references. So both of them are array references. Both of them are array references. So these are the differences. So the points that we have learned how to declare till here. Then some variations I have shown you. You can have multiple references and you can declare references like this also. Both are array reference. And if you give bracket along with the variable, then that variable becomes a array reference, and this is not an array reference. Right? So take this one. These are the various ways you can declare arrays. Now, let us write a complete program for having some array and accessing all the elements of an array. Class array test. Public static void main string args. Now, here I will declare one array integer a, and I will directly initialize the elements 2, 4, 6, 8, 10. Array is created. Then I want to display all these elements, all the elements of an array. How to display them? For, see, one thing. This is an array. Okay, I will draw it here. So before using that, I will show you this diagrammatically. 0, 1, 2, 3, 4, and these elements are 2, 4, 6, 8, 10. I want to display a of 0, then a of 1, then a of 2, then a of 3, then a of 4. So I want to display all of them. So what I'll do is, I will say system.out.println a of I. System.out.println a of I. So here I will say 0 first. So now system.out.println a of 0. So what will be printed? A of 0 will be printed. Next, I will write 1. So if I write 1, then what will be printed? A of 1. So like this, I want to print all. So instead of writing 0, 1, 2 here, can I write I here? Yes, you can write I here. You can use a variable there. Then that variable should be changing the values from 0 to 4. So okay, I can write this using loop. So repeatedly, this will be A of 0, then A of 1, A of 2, A of 3, so on up to A of 4. So I can take I here. So I is nothing but a counter here that is starting from 0 and it will end at 4. So I assign 0, I less than 5, I plus plus. So this is how all the elements of an array are displayed. So system.out.println, it will print. First time I is 0, so A of 0. Next A of 1, then A of 2, I plus plus, then A of 3, I plus plus, A of 4, I plus plus, I becomes 5, it will stop. So it will print all those elements. So you can take this program. Now we will learn few important things about array. Few more important things. See, what is the length of an array? 5. Size of an array, that is 5. So I should know what is the size, then I should write down 5 here. This was the practice in C, C++. But in Java, array is an object. Array is an object. So it is having one property called length. Every array have a property called length, and the length of this one is 5. Length is 5, means 0 to 4, total 5. So every array object have a property length. So instead of writing 5 here, I can say I is less than a dot length. So when you access the property, you can use dot operator for accessing it. So this is how you can display all the elements. So this is a change here. You can see I have written a dot length. So this point you can note down that array is object in Java. Array is an object in Java, and array object will have an attribute or a property called length. Array is an object in Java and it will have a property called length, and that length can be accessed using dot operator. The property can be accessed using array name and dot operator. Property can be accessed using array name and dot operator. So you can modify it. You don't have to copy everything. Just copy this loop and say you can write like this also, a dot length. All right. So that is 5. So I assign 0, I is less than 5, and I plus plus, and it will print this one. So same thing happens. So the benefit for the programmer is he don't have to remember what the size he has given. He is asking array itself, array, tell me what is your length. So it will tell the length and you can use it. So it's more like you are talking to an array or you are asking array itself, and the array knows its own length. So you don't have to know its length. So you don't know what the value it will write here. I don't know unless I go up and check, okay, 5 elements. Then I can know that 5 is the size. So you don't have to worry about the size. Just say a dot length. It will execute for that many times. This is a very useful property. Now next. Instead of this loop, I can say for integer some variable x a. I am doing the same thing. I want to print all the elements. Then what is this loop? This is the syntax. Declare a variable and write the array name here, collection name here, collection. This side it must be collection after colon. So declare a variable of same type, integer type, and collection. Now what is the benefit here? How it works? Let us see. This x will take the value first 2, then 4, then 6, then 8, then 10, one by one. So it will traverse through that array by taking elements one by one. So x will become 2 one time, then 4, then 6, it will become 8. So x will be changing the values. So x becomes a reference to this one, means the value itself, that is 2, then 4, then 6, then 8 and 10. So here I don't have to know how many elements are there, what are the elements are there, what is the size, nothing I should know, and even I don't have to say a of I or anything. I can simply say system.out.println. That's it. So x will become 2, 2 is printed, x will become 4, 4 is printed, x will become 6, 6 is printed. So it is just like this is x, right? So this x is first time 2, the next time, okay, here I will write, this is x, x will be this one, the next time x will be 4, next time x will be 6, x will be 8, so on. So when you say x, it is 8. So does it mean that if I say x plus plus, their values will change? Yes, their values will change. Their values will change. Alright, so it is a reference to all those. Reference means it's not a pointer, but it is representing the same thing. So this is a better option. So what do you call to this loop? This is called as for each loop. So for each loop will access all the elements of an array, whatever the size may be. It will access all the elements of a collection. It's not just meant for array. It's very powerful loop. It helps a lot. So it has reduced a lot of extra code written by programmers. So this loop has brought a big change in programming in Java. And this loop was introduced in Java 1.5 version. This was introduced in Java 1.5 version, and this has reduced a lot of efforts, right? Used to be done by the programmer. So this is representing all the elements in this array. So this is, yeah, this is useful for collection. So through an example, I have explained you for each loop. See, already we saw the loops, but that time I did not show what is for each loop, because unless we have an array, it's of no use, we cannot explain it. So take this one. So the point that you have to note down, I'll just repeat them. So instead of dictating, I'll just repeat them. So the point you have to note down is for each loop is useful for collection. So it also works for an array. So x will be a variable that is representing all these elements of an array one by one. So this will traverse through an array by taking one element at a time. That's it. Sorry, class array test. public static void main. Now here I have an array integer a. New, I'll take the same elements 2, 4, 6, 8, 12, 5, 9, 3, 7. So I have some size array. Okay. Now I will write on few pieces of code like finding the sum of elements or finding greatest of element, finding minimum of elements. I will write on few programs on this one so that you can practice on this. So array elements, how to access array elements. So simple program. So quickly we will finishing this one. See, this is an array I have. Then I want to find the sum of all the elements. So I should take sum as a 0 initially. Then how I can add all these elements. So I cannot add all the elements at once. So I have to go on adding one element at a time in sum, right? So whatever is sum is, suppose sum is 0. So add 2, sum becomes 2. Then add 4 to that. So first time sum is 0. Then 0 plus 2, so this becomes 2, sum becomes 2. Then 2 plus 4, sum becomes 6. Then 6 plus 8, sum becomes 14. So in this way, I have to go on adding. So whatever the sum value is, in that you add the element. So this is sum, and in that you add the element and store the result in sum again. So store the result in sum. So we get new sum. So that type of logic we can write using for each loop for int x colon a, then sum assign sum plus a of, sorry, not a of I have to take x because I'm using for each loop. So system.out.println x. So you can try this program. I'm not explaining you the details of the logic. This is taught in first year in C language programming. Just as a revision, I have given a simple program. So with this, you can try out various other things by yourself. So this program is for finding the sum of all the elements of an array. Finding the sum of all the elements of an array. Now, I'll just make a small change to find a largest element in an array. Largest element in an array. So, for that, I want to find max. So, I will declare one variable max. Now, to this, I should assign some, which value I should assign? I am finding maximum. So, initially, there should be something in that variable maximum. So, shall I take 0? So that anything above that is maximum, means 0 is minimum, so I should have some minimum number. So for that I can take 0, but the numbers can be negative also, so I should take some negative number. Which number? Minimum number. So one of the option is integer dot min int. I'll explain about this afterwards. So integer is a class available in Java. Then you can say min underscore int. So you get the minimum integer value, right? So you can get the minimum value. And here I can say what? For each integer x in a, if x is greater than max, then change max to x. Then say system.out.println whatever the max value that we got, max. Now this is sufficient. You can find out min also. I have shown for max. Now likewise, just I have shown you how to find max. You can find min, and also you can find a range. Range means the difference between maximum and minimum. You can find that one also, and various other things that you can do. You can find the average of all the elements, right? You can sort the elements. So lot of algorithms, lot of procedures that you can write you on array. So as a practice, you can perform the operations on an array. Now next is two-dimensional array. How to create and access two-dimensional array. Let us check this. 2D array. See, the one which we were creating, this was single dimension array, right? Int of size 5. I am taking small size. Reason is when I draw any diagram, it will be a small diagram. If I take 50, 100, it will be a big diagram. So for explanation purpose, I am taking 5. Okay, it's not my lucky number. So depending on your requirement, you can take any size. Now this is one dimension array. Then how to create a two-dimensional array? Two-dimensional array integer a, I'm using same name, right? Instead of confusing you with many different names a, b, c, I'm using same name. New int of size 3 and 4. 3 rows, 4 columns. 3 rows, 4 columns. So how this array looks like? This will be an, okay, below this one only I will draw this. This is an array, and these are 3 rows, 0, 1, 2, and 4 columns, 0, 1, 2, 3, and 4 columns, 4 columns. This is how a two-dimensional array looks like, but we visualize it like this: 3 rows, 4 columns, 0, 1, 2, 0, 1, 2, 3. We visualize it like this because this is hard to work on this one. So this is easy. So we get a two-dimensional array like a board, right? A rectangular or square. So we get a chessboard like thing. Okay, so all these boxes, any location you can access, like here if you want to store some value 15, then you can say a of 1 comma 2 assign 15. So you can use two indices. Now in this array I can say A of 1 comma, sorry, we say comma, though we don't write, 1 comma 2 assign 15. So 15 will be stored in that location. See, this is 3 rows and 4 columns. So you can access any location in this one. Alright. So this is two-dimensional array and this is how it looks like. Then one more thing. If I say a dot length, what I get? A dot length is 3. Then if I say a0 dot length, what I get? 4. And if I say a1 dot length, then what I get? 4. So it means if I say a dot length, I get this length. If I say a0 dot length, sorry, a0 dot length, then I get the length of this one. So same way I can get the length of this and this also. So just a dot length will give you number of rows, a0 dot length will give you number of columns in first row and second row and so on. Like we are taking with the same dimension, that is balanced number of columns we have. So you can take a of 0 or 1 or anything, so that is sufficient for you. So a dot length and this one. So these are the two things, how to access number of rows and number of columns. So this is the method of two-dimensional array. So more methods we will see. First you take this one, creating two-dimensional array. Creating two-dimensional array. It is created like this, but we imagine it is like this. Integer a assign new integer 3, 4. This is one method of creating array. First method. Second method, integer a, I want to directly initialize the values. That was just creation. I want to initialize the values. So for initialization, 1, 2, 3, 4, first row, then 2, 4, 6, 8, second row, and 3, 5, 7, 9, third row. So I have 3 row and 4 element in each row. So this is 3, 4. So 3 rows and 4 columns. So I get the array like this with the filled elements. Okay, I will not draw this one. So I'll get all these elements filled. So okay, this rectangular, I will follow this method for showing you. So this is 0, 1, 2 and 0, 1, 2, 3, and the elements are 1, 2, 3, 4 and 2, 4, 6, 8 and 3, 5, 7, 9. Then, so this is how you can create as well as initialize. And also you can do it in two steps. Instead of one step, you can do it in two steps. That is A, assign new int of 3 rows, 4 columns. This is also allowed. You can do it in two steps. Next, fourth one, you can declare by writing the subscripts on this side also. Okay, assign new int of size 3, 4, and even you can write one bracket on this side and one bracket on this side also. I will not write this new now. You know well that you can create it. Then sixth method, you can also have two brackets along with integer and say A, and also if you say B, then both of them will be two-dimensional array, because this itself is integer 2D array. Then A and B both are of type two-dimensional array references. They will be references. Both will be array references. So these are the various ways you can declare. Like one more thing I'll show you. Seventh, integer bracket here, then this one, then B. So can you tell me what does it mean? This is a single dimension array. B is a single dimension array reference. What about A? One more bracket is having. So it is a two-dimensional array reference. So A is two-dimensional, B is single dimension. So when you write this dimension along with the data type itself, so it will apply to all the variables that you write on that side, right? So B is single dimension, A is two-dimension. So take this one, okay. Both A and B are 2D are 2D references. A is 2D reference and B is 1D reference. Okay, this is A is 2D reference. That's it. Now this initialize one, so already I have some values. So let us work on this one. Now the point is I want to access all the elements of this array. I want to access all the elements. So diagrammatically it looks like this. So this is a reference to this array and this is having the values 1, 2, 3, 4 and this is having the values 2, 4, 6, 8, and this is having the values 3, 5, 7, 9, and these are indices 0, 1, 2, 0, 1, 2, 3. This array is created like this. Now I want to access all those elements. So what I want to do is I want to display all the elements. So let us see how I can display. Using for loop, I will show you. For integer I assign 0, I is less than rows. The first for loop is for rows. Then a of a dot length. This is for this one. Now, before writing, one thing I want to show you that, see, this is a two-dimensional array. For accessing single dimension array, how many loops required? Just one loop, right? And for accessing two-dimensional array, we need two nested for loop. So better I will erase this and I will write again and show you in a simple way. See, I just want to display this row, okay, that row. So for integer j assign 0 and j is less than what? This length. So what is the length of this? A of 0's length, this is a reference. See, this is an array, this is a reference to an array, and this is a reference to this array of references. So this size I want means the size of this one. So a of 0's size. So int j assign 0, j is less than a of 0 dot length, right? Then j plus plus. Then here I can say system dot out dot println a of 0 j. So which elements will be displayed? Can you check them? A of 0, A of 0. Then j. What is j? J is taking the values of 0 to 4. 4 it will stop, up to 3 it will work. So 0 to 3. So this will become 0, then 1, then 2, then 3. So 0, 0, 0, 1, 0, 2, 0, 3. So it will print all these elements. So this loop is for printing just first row of that 2D array. First row of that 2D array. Right? So a of 0 comma j. This is displaying only one row. I want to print all rows. So then repeat this. So at this place of 0, if I write 1, then which row it will be printing? It will be printing this row. And what is the length of this one? Same, 4 only. So it will take 4. So I takes values from 0 to 3 and it will print all the elements of row 1. Can I write 2 here? Yes. So is it possible that I write I here and I will change the value of I every time? So for this, I can write for integer I assign 0, I is less than a dot length. So what is a dot length? Length of this one, 3. So I plus plus. So this is how you can access two-dimensional array. This is one method. Okay, take it quickly. Now, instead of using double nested for loop, that is counter control loop, can I use for each loop here? Yes, we can use for each loop here. Let us check how to do that. Okay, I'll remove this one. Now, this outer loop we need definitely, and inner loop also we need. Now, I'll remove this. So I'll keep this structures as it is. Now see this. Outer loop is for rows. Inner loop is for elements, that is columns in that row. So outer loop, integer x a. Is it right? Integer elements. So I want elements. Is a having element? Is it a reference to this elements? No. A actual name of an array is a reference to array of references of 1D array. So this is a reference to 1D array, reference to 1D array. So if I write this, this is nothing but if I say this as x, this is like this single dimension array, this is single dimension array, single dimension array. So I should not say x here, I should take single dimension array A. So yes, A is a collection of single dimension array, and this is a reference to single dimension array. So that's how it is becoming two dimensional array. So this is a reference of 1D array, reference of 1D array, reference of 1D array, reference of 1D arrays from A. From A, I'll get all. Then inner for loop, integer y from from x. Now what is x? One dimension array. Then what will be y? The values from that one. Values from that one. So this will be going through rows and this will be going through elements in each row. Y will be taking element from each row. Right? So you remember when we wrote first dimension array, one dimension array, this was just A. But now it is two dimension array, so this is 2D, so this should be 1D. Right? Element is of type 1D. Then this is 1D, so now this is an element, actual element. So you have to print Y, and this will be printing all the elements of a 2D array. So this is the method how we access using for each loop. So the first one should be reference type, that is single dimension reference type, and second one is element type. So that's all. In the next session, I will show you how to create a different types of array and the jagged array. Then we'll move to the next topic.